Today we will go over arc measure and arc length. We talked about arc measure before. So we said that the measure of the central angle it subtends in degrees, that would be the measure of the arc, meaning that in a given circle, if I have a central angle, let's say these are the points, and if I wanted to know, say, what is the measure of that arc, then if I knew the measure of the central angle, then it would be the same thing as the measure of the arc, meaning the measure of angle QPR, then that would be equal to the measure of the arc from Q to R. Okay, so that was a relationship. Now, the measurement of an arc is in degrees because that's the same exact thing as the measure of the central angle. Now, here we have the arc length. Now, the arc length is different because it is measured in units such as centimeters, feet, inches, and so on. Think of the arc length as a fraction of the circumference. Okay, so meaning that if I have a circle, then say I have an arc that goes from here to here. Okay, so this much of my circumference. Now, depending, okay, so that is going to be based on a central angle. So if that is my central angle, then I am looking at that much of the circumference. But if I had a larger central angle, say I'm going to go from here to here, okay, so that's going to be another central angle. And that means that the length of the arc is going to be much greater. So the arc length is proportional to the size of the central angle. Okay, so let's go ahead and write down that relationship. Okay, so we're saying that the arc length is a fraction of the circumference. Okay, so let's say that arc length is a fraction of the circumference. Now, we're also saying that it depends on how large the central angle is. That's how large the arc length will be. So, let's let's just say central angle for now. Okay, the central angle compared to how much out of the entire circle. Now we're measuring central angles in degrees, so I know that the whole entire circle is then 360 degrees. Okay, let me go over this one more time. So the arc length is a fraction of the circumference, meaning a little piece of the arc out of the whole entire circumference. Okay, we know what the entire circumference of a circle is, and we're going to go ahead and change that here in a little bit. Okay, now that is going to be proportional to the central angle out of the whole entire 360. Okay, it's just like I'm taking pieces. Okay, comparing how much is the arc length out of the entire circumference, because that's going to be proportional to the central angle that creates that arc length out of the whole entire 360 degrees. Now, another way to describe the circumference would be to call it diameter times pi. Okay, so as long as we know the radius, then we're going to be able to know the diameter, and we multiply times pi, and that's going to be our circumference. Now, for arc length, we are going to use a cursive L for it, or sometimes you're simply going to be told, here's the length of the arc. And for the central angle, let's just use a uppercase letter for it, A for central angle, and the 360 degrees, then that's going to remain the same. So notice that we have a few different variables. So the 360, that's going to be a constant all the time. Now I need to know what the central angle is. I need to know the length of the arc, and I need to know the diameter of the circle in order to say that this proportion is true. So remember that anytime you have a proportion, as long as there's only one variable, then you will be able to solve for it. So if I wanted to know the length of the arc, which is what we're going to focus on, then that means that I need to know what is the circumference of the circle. So I need to know information such as the radius. I also need to know what about the angle that creates such arc. And once I have all of that, then I'll be able to figure out the length of the arc. Let's go over a few examples. First, I want to find the length of arc QR. Now the relationship is the following, that the length of the arc compared to the entire circumference is going to be in proportion to the measure of the central angle compared to the entire circle, 360. In order to start working with this, I already have my central angle, which is 120, but I need to figure out my circumference. For the circumference, remember that you have two ways to find it. The circumference is equal to 2 times pi times the radius, or you can also say that the circumference is equal to the diameter times pi. So either way. Now this means that because my radius is 15, 2 times 15 is 30, which makes my circumference 30 pi. Okay, so we have that. So let's go ahead and now start making our substitutions. So we have that the length divided by the circumference, 30 pi, is going to be equal to the measure of the central angle, which is 120, divided by the 360 degrees. Try to simplify. Okay, that's going to be my advice for this one, because you're going to be able to possibly simplify so that you don't have to work with, large numbers. So in this case, I could simplify the right side. 120 divided by 360, that is going to simplify to 1/3. What does that mean? 120 is 1/3 of the whole entire circle, which means that the arc length should also be 1/3 of the whole entire circle, meaning 1/3 of the 30 pi. So it should make sense now if, let's just go ahead and rewrite length over 30 pi, that I should be able to rewrite this as, actually let me put it up here, length over 30 pi equals 1/3. So now let me go ahead and multiply both sides times 30 pi, and I will get that the length is equal to 1/3 times 30 pi. Okay, let's repeat what I said over here. The central angle happens to be 1/3 of the entire circle. So it makes sense that the arc length should also be 1/3 of the entire circle, meaning 1/3 of the circumference. Okay, so solving for this, it's going to be a very simple answer here. 1/3 times 30, that is going to be 10 pi. And that would be the exact answer. You don't need to put this in a calculator unless you're asked to round. Number 2, find the length of the arc ZY. So we're looking for the length of that. So how much out of the entire circle is represented by that arc? So once again, let's first of all go ahead and figure out what the circumference is. So the circumference is going to be equal to 2 times the length of the radius times pi. So that means that the circumference is 24 pi. So now that we have that piece, let's go ahead and make the substitutions into the proportion, where the length of the arc is going to be divided by the circumference, 24 pi. And this is going to be equal to the ratio 45 degrees divided by 360. Once again, we have two ratios, two comparisons. The arc length is a fraction of the whole entire circle. Central angle is a fraction of the entire circle. So let's go ahead and simplify this too. We can go ahead and simplify the 45 divided by 360. That is going to be 1/8. Okay, so what we're saying is that 45 degrees is 1/8 of the entire circle. So it should make sense that the arc length should also be 1/8 of the entire circle. So when I go ahead and solve for the length, so I'll have this expression, length divided by 24 pi equals 1/8. Multiplying both sides times 24 pi, then I will get that the length is equal to 1/8 times 24 pi. Okay, so this is going to be also very simple in terms of the answer. 1/8 times 24 is going to be 3. So the answer would be 3 pi for the length of that arc. So let me know if you have any questions about this. But again, the main thing is that we're looking at a proportion where both the length and the central angle represent a fraction of the entire circle, where the arc length, the entire circle, is represented by the circumference, and for the central angle, the entire circle is represented by the 360 degrees.